Download this code from codegive.com, link in the description below. OK, let's dive into crafting well-designed REST APIs, avoiding the common trap of the JSON junk drawer, and focusing on clarity, evolvability, and maintainability. I'll provide detailed explanations, rationale behind design choices, and code examples, using Python with Flask as a common and easily understood example, but the principles apply broadly. Core principles of good REST API design. 1. Resource-oriented ** APIs should be centered around resources, things the API manages. Think nouns, not verbs. A resource can be anything: users, products, orders, articles, documents, etc. Each resource should have a unique URI, uniform resource identifier. 2. Stateless ** each request from the client to the server must contain all the information needed to understand and process the request. The server should not rely on any prior context, session state, stored on the server side. This is crucial for scalability. 3. Cacheable * responses should be explicitly labeled as cacheable or non-cacheable. This greatly improves performance by reducing server load. 4. Layered system * the client shouldn't need to know if it's connecting directly to the end server or to an intermediary along the way, proxies, load balancers, etc. This simplifies the client and allows for easier scalability. 5. Code on demand * optional servers can provide executable code to the client, extending client functionality. This is rarely used in modern REST APIs, more relevant in older implementations. 6. Uniform interface * this is the cornerstone of REST. It means that your API must follow a consistent set of constraints, including * identification of resources * each resource is identifiable through a URI. * manipulation of resources through representations * clients don't interact directly with the resource but rather with its representation, example JSON, XML. They manipulate these representations to modify the resource. Self-descriptive messages * each message should contain enough information to describe how to process it. This is often achieved through media types, example content type, application/JSON. Hypermedia as the engine of application state, HATIO's responses should contain links to related resources and possible actions, allowing clients to discover the API dynamically. This is the most misunderstood and often skipped constraint. Avoiding the JSON junk drawer. The JSON junk drawer happens when you create a single, amorphous JSON structure for all your API endpoints. This typically means overloading fields * a single field might mean different things depending on the endpoint or specific condition. Inconsistent naming * fields might have inconsistent names across different endpoints. Lack of structure * the JSON becomes a flat collection of key-value pairs, difficult to understand and maintain. Future-proofing gone wrong * adding optional or unused fields just in case bloats the response and makes it less clear. Why avoid the JSON junk drawer? Maintainability * difficult to understand, debug, and modify. Changes to one endpoint can have unintended consequences elsewhere. Evolvability * adding new features becomes a nightmare because you have to consider the impact on every other part of the API. Client complexity * clients have to write complex code to parse and interpret the JSON, with lots of conditional logic. Performance * larger JSON payloads mean more data to transmit, parse, and process. Strategies for designing a clean REST API. 1. Define your resources clearly ***. Identify the key entities that your API will manage: users, products, orders, etc. Asterisk determine the relationships between these entities. To use standard HTTP methods asterisk get asterisk retrieve a resource or a list of resources. Asterisk post asterisk create a new resource. Asterisk put asterisk update an existing resource completely, replace the entire resource. Asterisk patch asterisk update an existing resource partially, modify specific fields. Asterisk delete a resource. 3. Use meaningful URIs asterisk. Asterisk use nouns, not verbs. /users, /products, /orders. Asterisk use plural nouns for collections. Asterisk use singular nouns with IDs for individual resources. /users /123, /products /456. Asterisk use hierarchical URIs to represent relationships. /users /123 orders, orders for user 123. Asterisk avoid long, complex URIs. Keep them concise and easy to understand. 4. Use standard HTTP status codes asterisk. Asterisk 200 OK asterisk successful request. Asterisk 201 created asterisk resource created successfully, used with post. Asterisk 204 no content asterisk successful request, but no content to return, used with delete or put. Asterisk 400 bad request asterisk client error, invalid input, missing parameters. Asterisk 401 unauthorized asterisk authentication required. Asterisk 403 forbidden asterisk authenticated, but not authorized to access the resource. Asterisk 404 not found asterisk resource not found. Asterisk 500 internal server error asterisk server side error. 5. Return meaningful error messages asterisk. Asterisk don't just return generic error messages like error occurred. Provide specific details about what went wrong. Asterisk include error codes for easier client-side handling. Asterisk use a consistent error format across the API. 6. Version your API asterisk. Asterisk use URI versioning, example /v1/users, /v2/products. Asterisk use custom headers, example XAPI version, 1. 7. Embrace pagination asterisk. Asterisk for lists of resources, always implement pagination to avoid overwhelming the client. Asterisk use query parameters for pagination, example page equals 1 and per_page equals 10. Asterisk include pagination metadata in the response, total number of items, current page, next page, etc. 8. Hatios, hypermedia as the engine of application state. Asterisk this is the principle that enables the client to discover resources dynamically by navigating hyperlinks in the response body. Asterisk Hatios provides a client with a set of resources and their corresponding actions, links. Asterisk the client doesn't need to hardcode URLs. Asterisk it makes API evolution easier as the server can change the URL structure and clients can automatically adapt to those changes. 9. Specific response structures asterisk. Asterisk make sure that each response has a structure tailored to the use case. Asterisk avoid the junk drawer strategy of putting optional fields everywhere. Asterisk keep the response format consistent for a particular resource. Code example, Python with Flask. Explanation of the code example asterisk. Asterisk Flask setup asterisk the code uses Flask, a lightweight Python web framework, to create the API. Asterisk data store asterisk the users and products lists act as in-memory databases. In a real application, you'd use a proper database. Asterisk resource endpoints asterisk the code defines endpoints for managing users, /users, and products, /products. *HTTP methods * each endpoint uses the appropriate HTTP method, get, post, put, patch, delete. *URIs are well structured and follow RESTful conventions. *status codes standard HTTP status codes are used to indicate success or failure. *error handling custom error handlers provide meaningful error messages. *pagination the /users endpoint demonstrates pagination using query parameters. *hatios the get_user endpoint returns a sample of hatios linking. *specific response structures the response structure for each endpoint is specific to that endpoint. The user and product entities don't share the same response format. There are no optional fields that apply only in some scenarios. Key takeaways *. Design for clarity, not future-proofing *. Don't add fields you might need later. Add them when you actually need them. Over-engineering is worse than under-engineering. Embrace versioning when you make breaking changes, introduce a new version of the API. Document your API use a tool like Swagger/Open API to document your API and make it easy for clients to understand. Test your API write unit tests and integration tests to ensure that your API is working correctly and to catch regressions. Use the right tool for the job. REST is not always the best choice for every API. Consider other architectural styles like GraphQL or gRPC if they are a better fit for your needs. Don't reinvent the wheel. Use existing libraries and frameworks that provide RESTful functionality. Think about security. Implement authentication and authorization to protect your API from unauthorized access. Evolvability best practices. One addition is easier than modification. Adding new fields to responses is generally safe, clients can ignore them if they don't need them. However, modifying existing fields can break clients. 2. Deprecation *. If you need to remove a field, first deprecate it by marking it as deprecated in your documentation and providing a warning in the response. Give clients sufficient time to adjust before removing the field entirely. 3. Versioning is your safety net. If you have a breaking change, release a new version of the API. This gives existing clients a chance to migrate to the new version at their own pace. By following these guidelines, you can create REST APIs that are clean, maintainable, and easy to evolve over time, avoiding the pitfalls of the dreaded JSON junk drawer. Remember to prioritize clarity and consistency in your design, and always think from the client's perspective. Good luck.